This part of our topic, set and operations on set, we want to look at special set of numbers. Now there are some numbers that are special in terms of sets, and they are the ones we mostly use in calculations. The first type of special set of numbers is what we call the natural numbers or the counting numbers. Now natural numbers or counting numbers are numbers that begin from 1 and it ends at infinity, or it has no end. So if numbers such as 1, 2, 3, 4, 5, 6, 7 and so on are there, then we regard them as natural numbers or counting numbers. So you see, with counting numbers, they can be counted. And please mind you, 0 is not part of counting numbers. So we have to take note of that. Now, the symbol for natural numbers or counting numbers is denoted by n. So it is denoted by the symbol n. So we are saying that n is a symbol for natural numbers or counting numbers. The next set of special numbers is what we call the whole numbers. Now, the whole numbers are numbers that begin from 0 to infinity. So unlike counting numbers or natural numbers, whole numbers are not starting from 1, but rather they start from 0. So these are given as 0, 1, 2, 3, 4, 5 to infinity. That is the dots here. Now, if you consider, you realize that it is denoted by the symbol W. So W stands for the whole numbers. So this is also an example of special set of numbers. The third one under special set of numbers will be the set of odd numbers. Now, odd numbers are numbers that are not divisible by 2. That is to say, when you divide odd numbers by 2, you should get a decimal number or a fraction. Now, the fraction is what can be converted into a decimal. That's why odd numbers, which are not divisible by 2, leads into fraction, which can also be converted into decimal. So what we are saying is, odd numbers cannot be divided by 2. And for that matter, they are called odd numbers. Examples of odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, and so on. These are examples of odd numbers. So odd numbers are also classified or qualified to be special set of numbers. Now the next special set of numbers will be a set of even numbers. Now even numbers are numbers that are divisible by 2. So even numbers become the opposite of odd numbers. So if numbers can be divided by 2, or if a number can be divided by 2, then that number qualifies to be an even number. So let's take examples of even numbers. We have 2, 4, 6, 8, 10, 12, and so on. So to infinity becomes even numbers. So don't forget that even numbers are numbers that are divisible by 2. And even numbers are examples of special set of numbers. So this set is a set of even numbers. Now number 5, we can talk about the set of prime numbers. Now prime numbers, as we saw from the video at the beginning of sets, we realize that prime numbers are numbers that have only 2 factors. That is to say, 1 and that number itself. What does it mean? If you take any prime number, you realize that the 2 factors are the same 2 numbers that can multiply to get a number, or those 2 numbers that can divide that number without a remainder. So if a number has a character such that only 2 numbers can multiply to get that number, then that number is called a prime number. So let's take examples of prime number. Prime number 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. There are many. So these are prime numbers. Now let's see the reason again. If we take 2, the 2 is a prime number because it has only 2 factors. That is 1 and the number 2 itself. So that means if we take 1 and 2, they are the numbers that can multiply to give 2. That is 1 times 2 is 2. Also, the 1 and 2 that are the factors of these 2 can also divide the same 2 without a remainder. So let's come to something like 17. 17 is a big number, but only 2 numbers in the number system can multiply to give 17. So the 2 numbers are 1 and 17. That is 1 and the number 17 itself. So if 1 times 17 will give you 17, that character where 1 and 17 alone can multiply to get 17 is what we call prime number. Is what makes 17 actually a prime number. And also the 1 and 17, which are the factors of this 17, can also divide the same 17 without a remainder. So that is why they are still factors of 17. So any number with only 2 factors, that is 1 and the number itself, that number becomes a prime number. So that is how prime numbers are. So what we are saying is Prime numbers also qualify to be special set of numbers because they are set of prime numbers. And these numbers in the set are examples of set of prime numbers. Don't forget that prime numbers have only two factors. That is 1 and that number itself. We are trying to say 1 and the number multiplies to give you that number, or 1 and the number divides that number without a remainder. So know how prime numbers work. The next special set of numbers will be the set of multiples of numbers. So the set of multiples of a number also qualify to be a special set of numbers. Now let us see why it is special. You see, for example, down here, I've given you 3, 6, 9, 12, 15, 18, 21. These are sets of multiples of 3. So 3 multiplying all the counting numbers from 1 will give us these numbers to infinity. So 3 times 1 will give you 3. 3 times 2 will give you 6. 3 times 3 will give you 9. 3 times 4 will give you 12. 3 times 5 will give you 15. 3 times 6, 18. 3 times 7, 21. So you realize that when I multiply 3 by counting numbers, it will produce this set of numbers. And multiplying 3 by counting numbers is what we refer to as multiples of 3. So if you have a set that contains the multiples of 3, then we are saying that multiples of 3 in the set becomes special set of numbers. So that is what we are trying to explain. So for that, we can conclude that multiples of a particular number, it may not be 3 alone, it could be all numbers. So multiple of a particular number or multiples of a particular number qualify to be set, and they are special set of numbers. Now the next, at number 7, will be the set of integers. Now the set of integers will be any negative or positive whole numbers. So if you take all the whole numbers in their negative form and all the whole numbers in their positive form, they form what we call integers. So if a set contains numbers such that they are in their negative and their positive whole numbers, it becomes a set of integers. Now if you check the examples, negative 5, negative 4, negative 3, negative 2, negative 1 forms the negative part of the integers. Then we have 0 in the middle, and then 1, 2, 3, 4, 5 to infinity forms a positive part. So this is a complete set. That is why it is a special set of numbers. Now the last one, which is at number 8, will be the set of square numbers. Now square numbers can be found such that if you square all counting numbers, the answer you get from them becomes what we call square of numbers or square numbers. Now square numbers also in another way has a meaning called perfect squares. Why perfect square? Those numbers can be converted into a square, or they are likely to become a square. So we take an example like 4. 4 can also be written as 2 squared. Let's take 36. 36 can be written as 6 squared. 100 can be written as 10 squared. And because when you square counting numbers starting from 1 to infinity, the numbers or the values or the answers that you're going to get are what we call the square numbers or the perfect square. So starting from 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and so on. So it will go till infinity. So don't forget, square numbers or perfect squares are counting numbers that are raised to the power of 2, or counting numbers that are squared.